Hello there, it's Jay's Vintage Junk, and today what I've got here, this is my spare charger for my Makita battery drills. This came in a job lot with a spare drill and some batteries and bits I picked up cheap on eBay. And actually, funnily enough, when I bought it, it was this, 2 drills and 2 batteries, and it was said that the batteries didn't work. The drills actually work perfectly, and in fact the batteries, when I charged them on my charger that I've got anyway, both batteries were fine, they worked absolutely fine. It turns out that this actually was the problem. And first, I could do with this down in the in my little workshop in the summer house, rather than keep having to bring batteries either up to the house to charge them or take my charger down there if I'm doing anything. It'd be handy to have this working. Now, what's wrong with this? The problem with this, it's an interesting one. I've got a Makita drill here, and as you can see, that battery is flat. So I've discharged that. It's an old-fashioned NiCad battery. So you really need to completely discharge these before you recharge them, unlike like the NiMH and later batteries, which you don't have quite the issue that these do. So anyway, that's pretty much flat now, as you can see. I'll take it out. We'll actually plug the charger in. It won't do anything unless we plug it in. When I plug it in, as you can see, the lights come on. As you can see, 3 flashing green lights, ready to charge. Take the battery, and we'll stick the battery in. And if you can see, the red lights come on, charging. And if I leave it long enough, it'll come all green like that, and it'll come up charging complete. The problem is, it'll come up charging complete and that light will go green, but the battery will still be completely flat. So although the actual logic in here seems to be working okay, it's not actually producing any voltage to actually go into the battery to charge it. I'll just demonstrate that. I mean, I won't leave it to charge fully, but we'll leave this battery just in here for say 10 or 15 minutes or so, then I'll come back and we'll try it in the drill again, and we'll see if we've because after 10 or 15 minutes there should be enough charge in the battery to actually run the drill at full speed. It just wouldn't last very long, you know, it'll only last a minute or two, but it would prove that the charger is actually putting some voltage into the battery. So I'll leave that on there for say 10 or 15 minutes or so, and we'll come right back. Right, that's been on there. It's actually probably been about 15 or 20 minutes, because I had to nip out and do a few things, and I've come back. Obviously it's not come up with charge yet. This is a fairly new battery, and it usually takes around about 50 minutes to an hour to fully charge on my proper fully working charger. So like I say, we'll probably go through that on this. Like I said, the only problem is it's not going to produce any charge in the battery. We'll unplug that. Like I said, the charger recognises that the battery's been removed, so the logic in the charger definitely seems to be working. If I plug it back into the drill, I mean, we might get a little bit of speed, but no, look, it's not put any charge into that battery. So let's get that unplugged. Let's take this thing apart and see if we can figure out what's wrong with it. Right, we'll make sure we are definitely unplugged. Put the plug over there. Let's get the bottom off. First thing we're going to look for is dead simple stuff. Is there a fuse in line, anything like that? Is there a broken contact between the power and like the terminals that go to the battery? Basically we're going to check for simple things like that first. Right, let's get this, we'll get the base off and get that out of the way. 4 screws there. Right, and we can lift. This actually looks quite complicated. We'll lift the board out, and that actually feels quite warm. Not mad hot, but you know, it's definitely been running. So the question is, why have we got no output from it? Now this is going to be one of these instances where we are probably going to have to do some checks and measurements on this with it actually live and open on the bench like this. So this is something where I will say, you know, if you're not experienced with stuff like this, it's probably best just to take this as, you know, an educational video rather than actually try and do what I'm doing, because you do expose yourself, you obviously, to live mains when you're working on something like this and you're actually trying to diagnose a fault on something like this. Now, one thing I have just noticed, which is not going to be fun, is that a lot of the parts here are actually potted. They've got kind of like a potting compound down here, actually holding them in place. What I can't see are any obviously blown capacitors. That's the main smoother there, high voltage. So that'll be like a 400 volt cap at that's 400 volts, 68 UF. They actually very rarely fail. It's very unlikely that that part fails. It's more these capacitors, especially these ones on the output here, are likely culprits. I can't see any physical sign of distress on any of them capacitors, because so we will check them, but I would not suspect those immediately. I cannot see any form of fuse, like a fuse on the board or anything, so I don't think it's anything like that that's popped. I think it's much more likely it's probably either going to be something to do with one of these ICs or one of these either FETs or power transistors around here. That is most likely what's actually going to be at fault. I don't think it's going to be the main switching transistor, which is the one that's round here, for the simple fact that we know that we've got some voltage getting over onto this part of the board here, because the LED's working, it's going through its actual charge cycle, it's just not outputting any voltage where we'd expect to find the voltage. So I think one thing we should actually probably first have a quick look at is powering this thing up and seeing if we've got any voltages on. Let me get you around so you can see it. Basically, we've got these connections here which go to the connections on the actual top of the charger there, which actually connects to the battery. Now, on the battery itself, our main connections are that one and that one there. We also have that connection and that connection there and there for a temperature sensor inside the battery, which is a safety feature that basically when this battery is charging, if the battery starts getting too hot, that sensor in there will register that the battery is getting too hot and tell the charger shut down, basically, and it turns the charger off and obviously prevents a fire. So what I think we've got is we've got a red and a black, which I think will be our positive and a negative, and then we've got a white and a yellow, which I think are our two sense wires from that temperature sensor that's actually in the battery. I don't think that's the issue, because if that was the issue, we'd probably be showing like here where it says delay charge too hot, so it'd be showing those flashes or something like that if there was the issue was actually with that part of the circuit. I don't think that's the problem. I think the problem is most likely going to be one of these, they're either going to be FETs or they're going to be power transistors here. I think one of them has probably gone, and that's why. It's either those or it's whatever controls those, because if they're not getting obviously a switching voltage, they're not going to switch, so they're not going to provide the voltage to here. So what I'll do, I'll just pause the video for a minute and I'll have a quick look around the circuit, because this is actually the first time, you know, I've opened this thing up and actually had a look at it, and I'll see if I can figure out basically how this is connected up, and then we can have a look at taking some voltage readings and actually see if we can figure out what's gone wrong with this. So back in a sec. Right, okay, I've just got you a slightly better angle here. Now I've got it with a battery in. I'm just going to plug it in. Now obviously we have to be super careful around here. We've got mains there exposed. We've got 400 volts DC down there on that capacitor there as soon as we apply power to this thing. So this thing is dangerous. We've got a fuse there with mains on it right up there. Like I said, I don't recommend doing this unless you really know what you're doing. But we do need to take some voltage measurements with the power applied, and preferably with the battery in, so it's actually in the condition where it should be charging the battery, and we can see what we're actually getting. So I'm going to plug this in now. Okay. Let me see if I can see whether the LED is illuminating on it, so I can make sure it is actually in and charging. Yeah, and the battery mustn't be quite in because it's not coming up as it's charging, but we'll have a look now. Yeah, we've got a green. We've now got a green LED on, so supposedly this should be charging the battery. You can see my test meter here. Hopefully you can see the display on that. And let's see if we've got any voltage actually going into the battery. So that's the ground connection there. And this, on this far side, is the positive connection. So let's see if we've got anything there. Now that's not good. We should not be seeing a minus voltage there. We should be seeing, you know, plus 15 volt. This is a 14.4 volt battery, so I'd expect to see like 15.5 volts, possibly even 16 volts while it's charging that battery. Minus 2 volts is not what we should be. It's not what we should be seeing here. Well, I will say this battery, this charger is it's a fancy charger. It can't just charge these 14.4 volt batteries. It can charge any of the Makita batteries from the 7.2 volt batteries all the way up to the 14.4. So there's various switching and things that this charger is actually doing. Like I said, it is not just a straight charger for a 14.4 volt Makita battery. Let's just double check on that voltage, because that was definitely strange. Yeah, we have minus 1.8 there. There we go, it's minus 2 volts. Now, like I said, that should definitely be a... no, I don't have the leads reversed on the multi-tester. We're definitely in the right way around there. So let's disconnect this again. Let's switch the meter off. Let's pull the power. And we'll wait a minute because we could still have a charge on. In fact, let's have a look with the meter and see if we've still got a charge on that capacitor there. So we'll set that to the 600 volts range. Let's see if you can see that. And this is the capacitor in question. If we go across there. Fortunately, there is some form of bleed on this board, because that's already down to 0. A well-designed switch mode power supply will have some way of bleeding that capacitor off. Otherwise, you as a technician, you get hold of the board, you put your thumb across that capacitor there, and it bloody hurts, I'll tell you that. Right. I'm wondering actually whether I should disconnect, because I'm going to restraining these here. So what I think I might do is just get the desoldering station out and just disconnect that from there from the time being. I mean, we could even just run some wires temporary, so we can put that to one side and actually work on this board, and we're not quite as constrained as we are now. So I'll just do that. All I'm going to do is, like I said, just desolder that so we can actually look at the board a bit better, and then, like I said, in the future, if we need to do some more diagnostics with it powered up, we can what we can possibly do is, like I said, run some wires, and we can have that just a bit further off there. So back in a sec. Right, okay, as you can see, we've got the board now just playing out on the bench here, and I've been doing a little bit of tracing round on the board, and this connection here is our plus voltage, whether it be, like I said, 7 point whatever you're up to 14.4 volt, whatever the charge voltage is, comes on this pin here. Now it goes across there, and if we look on the other side of the board, that is this wire link here, which you can see disappears into that horrible potting stuff there. If we look on the back, in a direct line there, it re-emerges here. Then we've got some big solder points around it, which I think is that, well, it's either going to be an FET, a switching a power transistor or something like that. I can't see what it is because it's absolutely caked in all this crud. But what we can do, we will get a good ground point and we'll have a check round, see if we can see any voltages around there, because I have a feeling that's probably where our problem lies. I think probably we're getting something to that. It's, like I say, it's probably either a MOSFET, a switching MOSFET, or a power transistor. If I had the circuit diagram for this, obviously I could just check that up, but I don't. So what we need to do is see if we've got any voltage going to that device, and if we have, then there's a good chance that it's probably that device which is what is actually faulty. So we'll switch the supply on. Obviously, as I said before, you have to be incredibly careful and know what you're doing when you're doing this, because this board will be energized with not only mains voltage up here, but like I said, we've got a big 400 volt 68 UF capacitor there, which can hold quite a charge. We've already checked that it doesn't actually, there's a bleed away on this, so it will bleed the voltage off. But while this thing's powered, obviously, like I said, if I touch that, I will get one hell of a belt off it. So basically, it's a one-handed job. That's why I use that croc clip like that. So I'm only ever using one hand and one probe actually on the board while I'm working on the board while it's live. So we'll plug the board back in. There we go. So the board's energized. You can actually see the LED is flashing to say you have no battery in, but we should still possibly see what we've got there. We're not showing anything there at all. We might actually have to do like I said before and connect something up to the top here and connect it to those pins so we can actually simulate a battery being in while we take some of these measurements. But let's have a look round over here, which is where that transistor is. Oh, like I said, it's either a transistor or MOSFET or whatever. We've not got anything there really. Let's try some of the other pins on it. Nothing there. Let's see if we can spot which one the other one is. Nothing there. Nothing there. We've got we've got two smaller transistors as well, one there and one there, which could be the switching transistors for it. Let's see if we've got anything on any of these pins. We don't seem to have really anything there at all. Let's try this one. Ah. Now that's more what I was expecting to find somewhere. So we've got 27 volts there on that pin. But we've not got that going anywhere else. It's just on that pin there of that, which, like I said, unfortunately is buried underneath all that all that stuff that they've stuck on the board, that like that whatever it is, that glue stuff. I think what we're going to actually have to do is clean off. Let me shut this off. So power that off there. Now we're connected to the ground line, so if I put my, in fact we're on 200 volts, we'll stick that up onto 600 and we'll just make sure that we haven't got any voltage left on that capacitor before we start touching the board. In fact, the safest thing to do is just go right across the capacitor like that. As you can see, there's nothing there. If you want to be absolutely super sure that that capacitor is safe before you do anything, take a screwdriver and short across the capacitor like that. If there was anything in that capacitor, you get a great big snap and a pop and probably damage a little chunk of your screwdriver, but you will know for sure then that the capacitor is definitely dead. No, I said what I think the issue is. I think our problem probably lies around here somewhere. But we've got all this horrible, it's like a glue, it's disgusting stuff. Can you see it? So what I'm going to have to do, I'm going to have to see if I can clean some of that up, so we can actually see in there and see what components we've got, because I think we've got a couple of transistors buried in all that lot, and I think that might be actually where the fault lies. So I'll have a go at cleaning some of this up and we'll come right back. Right, okay, we're back, and as you can see, I've got it all set up as I said I was going to set it up, with this connected by wires and everything. Unfortunately, I've accidentally fixed it. If we plug it in now, I'll just quickly demonstrate and then I'll explain what I actually found and what repaired it. But if we plug in, I've got a battery in the charger, and the lights come on that it's charging like it did before, but like I said before, I was getting no voltage to come out onto the battery. I take my probe now and I go on the positive pin there, 15.2 volts, which is just nice to be charging a 14.4 volt battery. Right, let me get this disconnected, because we better put this all back together as it should be, because like I said, I've got this all connected up on wires, and as I'm doing this I can explain to you what I found. It's annoying actually that I didn't really film it, but basically what I was doing before I started putting all these wires on here, I thought I'd better clean out some of that I think it's like a silicone. They've obviously stuck it in there to stop movement of components, and we'll come to that in a sec. You just get these wires back out of here. Right, and we'll get that off there, so we can get that connector back as it should be. So I literally just stuck these on as test wires so we could carry on diagnosing the faults, but unfortunately I've repaired it. We'll get these holes unblocked, and then we can get that connector back on. I'm just using my hand desolder pump for this. You don't need a fancy desoldering station for just doing basic work like this. I mean, Gadget UK takes like full 40-pin dip ICs off with a standard soldering iron and a solder pump like this. I do tend to use my my desoldering station for anything big like that, but it just goes to show that you don't need the expensive kit. You can do most things just with a solder pump like that and a soldering iron. Right, basically, what did we do? I'll get you zoomed in here. Oops. Now, do you remember me saying about all this horrible, like I say, I think it's like a silicone rubber, and it's put round to stop components moving, really, because I mean, this is an industrial device. These are used on building sites and stuff. They get thrown in vans and all sorts. So what they tend to do is big components like that capacitor around here, these smaller capacitors here, they tend to put this stuff around them to hold them in place, and it's an absolute pain when you want to start repairing something. So I took my little pick here and I scraped all that out from round here, and I cleaned it all out, and as I was doing it I noticed this capacitor here was loose. It was wiggling about. I thought, oh, that feels looser than it should be. You're feeling it compared with that one. Anyway, when I flipped it over on the board and I actually held it and wiggled it, yeah, we had a dry joint on both legs of that capacitor. Now bear in mind that capacitor, the whole of the bottom of it, all the way around there, all the way underneath the capacitor and everything, was completely covered in this silicone stuff. But somehow, I think, it had got a dry joint, I say, on both legs of that capacitor. Because all I've done, I thought, oh, that's loose, and I soldered it back in, just thinking I must have loosened it while I was scraping away the silicone. You saw how I connected it up there with the leads and everything. Connected everything up, went to test voltage, and there we are. We had 15 volts on the charge pin. So that must have that's literally all it was dry joint on that capacitor. Now I was certain we'd have like a switching transistor or something like that, or a FET, or you know, a power MOSFET or something that was faulty, or a drive transistor or something like that to it. I wasn't expecting to find a dry joint on a capacitor which was all potted around like that. That's most odd, but there you go. Anyway, let's put this thing back together. Let's get that battery out of there. We'll get this thing back together. This is the tricky bit, is getting that back in there. Let's hold it round that way so we can get it in. Okay, that's through there. We've got all. We're going to. Oh, I might have to just clean those pins up a bit. They're looking a little bit like I've got a little bit too much solder on them. Let's give them pins just a little dress up, and then they should go through. There we are. That should work. Let me get you zoomed out a little touch so at least you can see a bit of what I'm doing. Right, now we want the red one to where the dot is on that side, which is correct. We'll get that through and push that in place. Is that going in? Might just have to hold it while I solder the first one. If I could do with a little bit of extra solder on that. We'll get one to hold in and then we can solder the rest. Yeah, that's holding for now. That's soldered. That's soldered. That's soldered, and we'll just redo that one we did first. There we go. And put that. I'm not going to burn anything. That's nicely connected there. Right, let's put the board back in where it slots in. There we go. I think that's about right. That has to come out of there like that. Where's the base? Drop that on. I think we're in about the right spot there. I think we're quite sitting right there. There we go, that's got it. Just make sure that that wire, We don't want to trap that wire as we screw it in, that would be a bad thing. Let's push the wire in where it needs to go, which is in there. That's better. And we've got something trapped because that's not quite sitting down where it should do. That's in at the back there, but at the front, got it. That's in. That's in. That's in. Ah, there it is. Thought I'd dropped a screw then. Put that one in there. Okay. There we go. Let's get you zoomed out. Oops. Let's get you zoomed out a little touch. Get you up there a bit. Right, so moment of truth. We've got it all back together. Now we've got this battery, which, like I say, I'll show it in my drill. We're completely, well, they do have a little bit of a memory where they'll get a bit of charge back in them. So let's completely run that down. And that's, you know, there's no charge left in that battery. Completely flat. Let's plug in the charger. Put the green light on there. We'll plug the battery in. Make sure I put it in the right way around. There, as you've seen, we've gone red. And I will come back in about 15 minutes or so, and we'll see if it's put any charge in that battery. If it has, then I think we have a successful repair. So back in a sec. Right, well, that's been charging for probably about 10 or 15 minutes. It's not been charging that long, but it should be enough to give us a test, because as you saw before, that battery was completely flat. It had no charge in it at all. So let's give that a try. Put it back in the drill. Look at that. So I think we've got a successful repair there, and it was simple as, I think it was just a dry joint on that capacitor. But I mean, I did inspect the board prior to that, before I started cleaning that stuff off. Just had a quick look over the board, because I mean, that's one of the first things you check for, is dry joints, stuff like that, and I couldn't see anything. It wasn't until I picked all that silicone away and I felt that that capacitor didn't feel right compared with the capacitor next to it, and then when I checked and I whittled it, and yeah, we had a dry joint on that capacitor, resoldered that, and that's all it was. The charger's working again. So I've got a second Makita charger that I can put down in the summer house, because I have a Makita drill down there and a couple of spare batteries, and I don't keep having to bring the batteries back up to the workshop up here every time I need to charge them. So I hope someone might find that useful. Like I say, on these things, check for, like I said, capacitor leakage, because then capacitors can fail, and check for dry joints. Don't necessarily do what I did and assume it's going to be something like, you know, a switching transistor or something like that's failed. It could be a dead simple fault like that. I mean, even if you're not technical, obviously don't do the tests that I've done where I had it live, but you could take the bottom off this thing and go over the solder points, you know, reflow them, and in this case, that would have probably actually fixed this unit and got it up and running. Anyway, I'm going to leave it there for now. I hope you enjoyed this little video on this repair, so I'll say thanks for watching and goodbye.